Welcome to another Friday Lunch and Learn sponsored by the Tampa IIBA. We've been talking about a lot of subjects over the last couple of months. This time we're gonna tie it all together by talking about data, how to get it and how to use it in various contexts. So I've done simulation for a long time, different kinds, many different industries, architectures, applications, and I've used all these same skills to learn about and talk about business analysis, because at the end of the day, it's really systems analysis and getting a lot of people to work together to do something complex. So, our friend Richard Frederick gave a really nice series of 20 talks late last year and into the beginning of this year. And I've been doing similar things for a long time, and I still learned a lot of new things from what he had to say. So I think, A, you should hire the man to provide training for your organization, one. And two, you might want to go ahead and review the talks and the slides, which I linked here at my website. Follow that link. Um, so just so you know, these slides are hosted on my website under the portfolio page under presentations. This one is presentation number 8 in the BA series. His LinkedIn information is listed at the link also. So I've talked every week that I've given one of these about a framework I use for doing business analysis. And there is a streamlined version of it that I made all artsy and color coded to really talk about the most important parts of what we do. And that is figure out the problem and what you're trying to accomplish. That's the intended use. The conceptual model is the as is state, it's the current system that you're working with. Then we talk about data. Then we figure out the requirements, which is the abstract form of the to be state, both in terms of functional and non-functional things that you need. Then we do design, which is the detailed to be state. Then we do implementation and various kinds of testing. And we don't necessarily do all these things one after another. We cyclically, iteratively, and interactively review things in each phase with customers, team members, stakeholders, and whoever until we are all in agreement and all have a shared understanding. Then we move forward. But you don't necessarily want to be hamstrung by having perfect understanding in every phase before you can move forward, because what you're really trying to do is be aware of every phase and have people thinking about every phase from the jump. So in reality, what you're doing is getting all these things going at the same time to a certain degree, and you can move forward and backward between participants in various phases of the process. As a BA, you especially want to be aware of how to facilitate everything all the way through. There are some ways this structure can be used. We can do waterfall or scrum. We're using the same elements, we're just doing them in a different context. Hybrid is when you're doing kind of design and implementation and even requirements at the detailed level on kind of an iterative discovery based way, but you're doing it in the context of a larger architecture. And there are some more things, whether we're improving an existing project, employing or building a simulation, or doing something new. I've talked about all those in the past. So I want to differentiate that sort of six-phase cycling procedure. That's called the engagement. That's what project teams and BAs actually do to affect a change that serves customers. So the system is what we analyze and either build or change to serve customers. That's our process, that's our product or whatever. And it may exist and we're going to change it, or it may not exist and we're going to build it. I call the solution the change we make to serve customers. So I make these distinctions so we have a vocabulary that gives context to what we're trying to accomplish as we're working together. Data is always an important part of this. I identify four kind of theoretical classes of data. One is descriptive data. When you do the conceptual model, you're doing something called discovery. And that is when you're figuring out what's going on with the current system. Data collection is how you characterize the system in more detail once you've discovered it. And the way you do that is driven by your requirements and design. And in reality, things aren't this cut and dry. All these things are iterative. They're a little messier than this, but this gives you a starting point for thinking about it. Um, Control information or governing parameters give you a basis in terms of control set points, thresholds, business rules and so on, and they get built into the implementation. And then generated output is what the system is supposed to produce. That could be information, it could be physical products, it could be a lot of things. But as we'll see going forward, information really comes into and goes into and comes out of every part of a process or system. So that's what I'm showing here. We have our basic process or system in the middle, and we're showing data either describing a system or that we need to analyze the system or what we discover about the system or what the system or any component of it generates. So this is entirely notional. This depiction, it just shows that data is heavily involved in a lot of ways, and you can make use of all of it in different contexts. And I show one kind of collection of data for all these, but there are multiple kinds that may be associated both going into and coming out of every component of a system. So, discovery is a qualitative process that identifies nouns and verbs that describe what's going on. It's how we go from something we don't know about when we start to something we clearly understand and document as we proceed. Um, if you are an outside consultant or vendor, you may know a lot about how to analyze a particular kind of system, but you don't know the details of a system. So you may start with a kind of obscured view of things when you start, and you'll end up with a clear one. If you're already familiar with the system, those codes and question marks may only be covering you can visualize the parts of the system you don't know, some subcomponent where there's a problem, some new needs or different needs that people have, and so on. So it's just a way of illustrating that. You do discovery before data collection, so you know what data you need to collect. And there we go. All right, so data collection is how that's a quantitative process, and it's how we go from knowing what the system is to being able to characterize it in detail. So to make this more clear, think about everything you need to know about a car in different contexts. What you need to know about cars going into or out of gas stations, for example, is very, very different than what you need to know about a car if you're trying to deal with financing or insurance or design or the logistics of making spare parts available or anything else. The things that you learn and discovery and the data you collect in data collection are germane to the actual problem you're trying to solve. So again, that's why you iteratively have those communications with all the engagement participants so you stay on target. You do what you should do and don't waste time with things you shouldn't be doing. Methods of discovery, there are a bunch of them. The main thing is that you need to be conscious and do these things on purpose. There were a lot of techniques. I've used every single one of these in multiple situations all over the world and certainly all over North America. And then data collection, there are a whole bunch more ways of doing it. One, you can physically observe operations as they happen, and you can record events as they happen with time steps and other data. There are a lot of electronic ways of doing it, from compiled records, from real-time systems, from sensors, from software, and so on. I've done all those. In a lot of cases, we did data collection from taking video of things, and then we could break down and do observation and take notes and make log sheets from the video if too much is happening, to be able to capture it all accurately in real time. We can also do surveys and reviews of the things that were actually produced. This graphic in the lower right is a archive data review program I made for a level 2 system in the steel industry that recorded all the operational settings and the events, and also the state of every piece of steel over its entire journey through a steel furnace. So that would be an example of software event logging. The system I worked with, the CI/CD microservices based IT infrastructure at Universal Studios Orlando. They basically recorded everything that happened in that system. So also, data collection can be really fun, emotionally uplifting. And if it's done well, you get some soaring orchestral music, as in this movie they made basically about data collection. Wait for it. All right, that's what I call data collection. So when we're collecting things, I don't want to make that go away. Here we go. there were different classes of data or characteristics of data we're going to collect. First of all, there's a type in terms of the way it's stored in a computer. That's numeric, text or string, enumerated types, and logical types, and combinations thereof, and doing odd things with my apostrophes. Um, and there's also whether data is continuous or discrete. So many numeric values like temperature or whatever, or continuous, and those are intensive values. But counting values like the fact that there are four of something, those are considered discrete. Deterministic or stochastic. The individual data points are not one or the other. They are what they are. That's more about how they're used. The possible range of values is important. You want to, and the format is also important. So you need to make sure those things are addressed. Goal values, higher is better, lower is better, or nominal is better. That's an important consideration. The number of samples you need, will touch on that in more detail directly. That's an important consideration. The source and availability of the data is important, as is the authority and ability to verify. So required sample size, there are a few different versions of equations you can use. This is one common form of it. It's something we usually use in data collection of border crossings when we were doing video and in-person data capture and breakdown. I call it a chicken and the egg thing because as you collect samples, the standard deviation of the now growing sample set may change. There were situations where we wanted to capture 400 or 500 events, but there are other situations where certain events do not happen that often. Um, Ideally, you'd like at least 30, but if you have less, it is what it is. And then typically that fact is probably mitigated by the fact that it's just not happening that much in terms of overall operation. So the accuracy might not be as critical. Once we get the data, we have to condition it for use. Some of it may be missing, and this is really in the context of entire records that are missing data items. So it's not like we're measuring a whole bunch of one thing and some of it's missing. It's we've got collections of 10 associated with things, and one or two of those may be missing from some record. There are different ways to address this. We can either do independent research or deduce from the accompanying data what the information should be. An example is if you have data that's reported A plus B equals C, and C is missing, well, you have the information A plus B, so you can derive C. A more complicated one is we simulated entire fleets of aircraft for maintenance and deployment. And one of the records was show where the aircraft took off from and landed. And if that information is missing in some records, well, you know that an aircraft typically operates out of a base for an extended period of time and doesn't flit around from place to place too much, at least not military aircraft. So if you got three flights, it's in location B, and then you're missing a data point, and then it's still in location B on the third sample. Well, you can guess on the second, it was probably in location B. In other cases, you can leave the record alone or you can remove it entirely. You could replace some data with the mean or median value for that column or that subcomponent. You can explore certain correlations or similarities. If you know one of the other elements of a record tends to be associated with a specific or limited set of values in another component, then you can use that to fill things in. And the main thing is to document everything you do that comes into assumptions, capabilities, limitations, and risks and impact, which is one of the standard steps in all this, although it doesn't get its own colored loop. There are some more things you can do with conditioning data. You may have to regularize it all so it all has the same units and formats. You may compile and merge information from many different sources so it's easier to use and so on. You should make sure that the similar data that's reported in different ways is consistent. So a bunch of hourly totals, for example, should match the total for a month. That's one uh, situation. By the same token, you need to be aware that if you have a yearly total, every month might not be the same. There's seasonality and other things going on. You have to check and see if things change over time, and you need to continuously see if you're doing things over time, who you get the data from, how often it's produced, and so on. This slide is one of the favorites of mine that came from Richard's talks. he touched on it many times. And it talks about how what we're doing with our increasing volumes of data is becoming always more sophisticated. So at the beginning, we were just dealing with data and using it to describe things. And but over time, and this goes back basically forever, none of this is new. Um, we were using it in a diagnostic sense to figure out what was going on. We were even doing predictive and prescriptive things. But as computers and automation have taken over, we're better able to find patterns through different visualizations and all the new artificial intelligence stuff we could do is letting different pieces of software and analytic capabilities find new patterns on their own. Um, if you've been on social media, that some of these can be problematic, but there are some really fascinating genetic algorithms that people are using to sort of go in and redesign systems. Um, One really interesting system I've seen is where a physicist will create some bizarre system of links with a light on it and then have the computer analyze a video of just the light moving around without understanding or being able to see what all the linkages actually are. And it applies a genetic algorithm which slowly over successive generations um, provides a better and better approximations of the movements that are actually seen. What it ends up coming out with is a constant that has to do with gravity, one that ones that have to do with the lengths and methods of connection and friction of all the different elements. It's really fascinating. So there's a lot going on. I'm sure you've done a lot of these things. Richard talks about having intelligent assistants. They are more toward the upper right hand corner. And in my work, simulation and model predictive control and optimization, that's also toward the upper right, but those are not quite all the way. Those are really human imposed automation. And that's what I've got for this week. Um, does anyone have any questions before I turn it over to Cliff? And hello, Mark. All right, seeing none for the time being, feel free to contact me at these points of contact if I can do anything for you, if I can answer any questions and so on. And Cliff, take it away.
Oh, hello, everybody. I hope you have a great Easter weekend. We probably should have skipped this this week, Bob, but that's okay. Um, I didn't even know it was Good Friday until yesterday. So hopefully everybody has a great Easter weekend. And if you have any questions, reach out to Bob, me, IIBA, anybody. We're always available.
Okay, have a great weekend and next week, everyone.